Welcome to Roof Truss Engineering webinar. We are excited to have you join us today as we explore the design of cold-formed steel roof trusses using Vertex BD. The session will be presented by David Cochran from Australia, who brings extensive expertise in this field.
Hi everyone, thanks for coming.
My name is Jukka Haho. I'm working as a product manager in Finland, and I will be your host in this webinar. And that's the agenda. And David, stage is yours.
Okay, so this webinar is aimed at those people using Vertex already and want to learn how to use engineering, but also those of you who may be using engineering and just want to check that the process that you're doing is correct. The engineering in Vertex is relatively simple, but there is a set process, specific process that you have to follow, and you've got to have the model prepared before you start engineering. So the video we have will go through all that, go through that process step by step. And if you've got any questions through the video, you can type them in there and then we can go through those afterwards. Welcome to Vertex Truss Engineering. Okay, I've got a model here that's almost ready to run engineering on, but I'll go through a few things first. So first thing you might notice is that we don't have any wall framing. Engineering does not look at the wall framing at all. It looks at the architectural wall envelopes. That's where it determines what's load bearing or not load bearing. So adjusting the wall framing makes no difference. It's just easier if you can run engineering without wall framing. It's just something that won't get in the way then. But it can be there if you've already done it. That's not really an issue. Another thing I should mention is that so truss engineering is just for trusses, just these main trusses. It does not engineer these roof panels. We do an FEA study on them. So roof loads get transferred to the trusses, etc., but we're not doing like a pass-fail as such. So there are a few things that need to be done before you start engineering. So one is these beams. If you've got beams and they don't have columns under them, then you need to go to properties and make sure this grounded button is ticked. That just tells engineering that that beam is fully supported. Excuse me. I think this beam I've left unticked so we can see what happens. It will just pop up an error. But for the most part, just pick one, go Control A, right-click Properties, and tick that grounded. All right, so a few things in the roof. You'll notice I've got these panel connections. So these represent screw connections through there. It's just these red squares with the X in them. So we're going to add them through connection details panels, and we use these two. So this one here is for down the hip, and this one here for the panel to truss connection. So you need to do that on all the panels. And you need to remember to do it for these gable ends as well. So this is critical in this case because if you don't add it in, all the load from that roof will get transferred down that gable truss. Now, another thing we've got to do is truss to truss connections. Sorry, it's my dog's barking. So these same sorts of connections here, we're just going to do that through that connection details and trusses, and for the most part you're going to use this direct screw connection. Now when we add that connection, it is always going to assume that the T, if you like, is the girder truss, and the truss butting into it is the truss being carried. Sometimes it can be the opposite to that, where you, let's say this hip truss was cantilevered and it might be carrying, or it might be carrying this truss, say, so this one would be the girder and this one might be the one being carried. In that case, you need to use this connection tie, and when you use the connection tie, it will ask you for the girder truss and the truss being carried, and that would determine the load path. You can also use this connection tie if you get the odd instance where this direct screw connection doesn't work. And sometimes it doesn't work because you don't have a vertical in the right spot. These trusses might be slightly offset. It can't find the vertical, so it can't add the connection. In that case, you can use that connection tie. All right, another thing to look out for is that this wall is right up under that panel supporting it. That's critical because if that wall's not under that panel, that roof load, all this roof load will get transferred back onto that first truss and that truss will fail. The easiest way to fix that wall up is to stretch it up above and then just use this clipping tool. Clip the wall back down, and that works pretty good. Okay, so once we've got all that set, we're pretty right to go and start engineering. Now, one other thing when we come to the engineering tab, make sure this roof panels button is ticked. Yeah, there's 99.99% of the time you just want that ticked. If it's not ticked, go into your template project, turn it on, save it. So any new projects, this is always ticked. Yeah. The other thing is the building code. So if you not sure of your building code, or if you picked the wrong one when you started the project, you can just come to here, building code, pick the building code that you need. So we'll use Australian Standard 2021, but these are the other ones available. All right. So first thing we're going to do is go to the ceiling. Or actually, before I do that, I'll just point out one other thing. The ceiling must have a sheathing layer attached to it. We'll expand those layers. So it has to have that sheathing layer. If it doesn't have the sheathing layer, you can't add wind loads, and you've got a problem. So if your ceiling doesn't have a sheathing layer, just go into properties and add it in here. But it absolutely has to be there. All right, so now we're going to go to the ceiling model pair and engineering. So the first thing we're going to do is add an internal pressure area. So I just hit the button. Now at this point it's drawn it round. It's hard to see there, but it's drawn a red dotted polyline around the external walls. We're just trying to tell it what's external as opposed to
internal, so this is the whole internal area, of course, and we're sort of trying to isolate this patio and this area here. So you got to read this a little bit carefully. It says define internal pressure areas also manually. So if you had two areas where you had a lot of external walls, you might add some points in manually. We don't need to in this case, so we just say no. So if I just show what that's done, hide. It's just this line around here is what it's added. So just make sure it's in the right place. Sometimes if you've got little columns that are drawn with the external walls, it might find that. If that's the case, then delete it, draw that in manually. Okay, so now we're going to come to wind loads. So down bottom left, select area. So I'll just select the ceiling, confirm. Now we are using AS 4600. So if you're expecting to use the residential code as an N2, N3, and so on, we don't have that code. We're using 4600. There are advantages to 4600. One, it lets us design with design commercial buildings, not just residential, but the codes are different. So, yeah. So what we're going to do is down here, we're going to pick the automatic define wind loads. If you're using a website like Checkwind, that can give you the wind speeds for your building site, you can use that and then fill in all this data. But if not, automatic. All right, so this is straight from the code, this page. So what we're going to do is fill in the basic wind speed, which is your ultimate limit state wind speed. So I'm in Brisbane, so that'll be 57 meters per second. And it's going to pick this automatically, which is your serviceability limit state. You shouldn't need to be altering this at all. If we pick another wind speed, right, that'll change accordingly. But we're 57 in Brisbane, and terrain category and wind region, we will be a 3B1. So 3, I think, being the terrain category, B1 is the region. Okay, this button, interior ceiling, is permeable. If you've got no ceiling, or you've got a suspended ceiling where the wind can blow that ceiling up, then you would tick this button. That just transfers the wind loads to the top chords. But for the most part, you will leave that unticked. This here is to do with cyclonic. So feature type, if you're on flat ground, pick flat. If you're on a hill, then you're going to have to pick one of these, whatever one's appropriate. Make sure this is filled in correctly. These heights here make a big difference to the design. So yeah, if you're on the flat especially, make sure that's filled in. Vertical distance, 5, that's just the distance from the ground to the top of the roof in meters, roughly. I don't think it has to be exact. But just make sure you put it in meters, not millimeters. It'll make a big difference. So yeah, 5, and then we'll say okay. And that's going to add our wind loads. Now I must have played in this project before. So normally if this is a brand new project, you'll have an arrow coming up asking for your wind direction. If you don't know the main wind direction, just point it to the long side of the building is fine, and that'll be worst case. Okay, now this is a bit that everyone forgets, they get to here and think it's finished. We're not. We must hit that members and trusses button. Okay, now this is that error that's popped up that I was talking about earlier with that beam. I can pick on this error, and it puts a big red arrow here pointing to where the problem was. So the problem's that beam. So I'm just going to close that, and we'll go into our 3D, find that beam, properties, make that grounded, and now I should be right. So let's run that again. So any errors are going to stop it at this point, and you've got to fix them. The warnings you can just read and take note of. So here we're going to add in the dead load of the ceiling only. So we're just talking about the ceiling, and I'll typically put like something like 0.15, 15 kilograms a square meter. So that is the plasterboard, ceiling battens, insulation, electrical, whatever else, everything below the bottom chord. So you can calculate that yourself, but it's typically between like 0.12, 0.15, something in that area. Yeah, and we'll just say OK. Now, select objects to design. We don't have any objects to design, so we can just say OK. And that's fine, and close. All right, so now we can go to the roof, and we're going to do much the same thing. So here, if we want to add point loads, line loads, area loads, we can do that here. So if I want to add an area load, for example, say OK, pick the just read down the bottom left, pick the master area here, and let's say I'm going to put an area load on top of that. Make sure that area load does not cross over the ridge. It has to be within that roof panel. So this is all putting this on in 3D. So if you've got a big area that's coming over two panel, put it in twice. If you've got point loads that you want to add to the ceiling, you need to add any loads for the ceiling. You can only use this point load button because you've got to add them to the roof here, and then in 3D move that point load down to the top of the bottom chord. You can't add those in the ceiling. Okay, so once we're happy with that, we're going to add wind loads. So we don't need to do the internal pressure area again, we've already done it, but we'll add our wind loads. So just pick one, Control A, confirm. And we're going to do the same thing again. It doesn't remember this side, so we just have to fill it in as to what it was before. And we were 3B1. And it'll remember this side. And OK. And just keep an eye that it's adding on these shaded areas to all of the roof panels, that nothing's missed. It might indicate you've got a problem with your model if it's missing something. Okay, so that's done that. So now we're going to run members and trusses. So you can especially look here to make sure it's all filled in. If you've got tiny little gaps in the odd spot, that's fine. Vertical truss member missing at support. Okay, so we've got one here on our gable, and we've got another one here on our this truss. So we need to go and fix those before we can continue. Which I forgot about. So this truss is not being supported. You can go and fix the envelopes and everything and put plane extensions. Whoops. or you can just move that end web like 50 mil or something, so it's sitting on there. Now the gable, I think I forgot to mention the gable end. The error that come up was this, it's missing a support at this point. So we'll fix that in a second. But the other thing we might want to do with this gable end truss is make it fully supported. Make sure that's ticked, that's on, and okay. So that'll mean that this end wall and that beam are making it fully supported, but it's still will have this error, finds this load bearing wall. Just shift those webs over so it sits roughly there, and that should fix that. All right, so we're in the roof. We'll come back so we can do members and trusses again. Hopefully it all goes through this time, which it does because this box has popped up, which is good. So now we can add the dead load for the roof. So don't touch the live load, that's out of the code. So the dead load, let's say it's a sheet roof, I'll be like 0.06. That's 6 kilograms a square meter. That's the roof sheet, roof battens, insulation, whatever else might be there. If you're a concrete tile, that would be something like 0.6. But let's say we're a sheet roof. The other thing, this makes a big difference too, this load shear factor. I think the code says it can be set that to 0.5. What that does is halves this value. And because this is a live load, this concentrated live load, that's already multiplied by the code by 1.5, so that's going to be like 1.6 roughly, so we can, which is quite a lot, 160 odd kilograms. So the code says we can halve this. So this is essentially people walking around on the roof, and yeah. Now the other thing here that's critical to fill in is these values, E and F. So your roof batten centers and your bottom chord restraints, ceiling batting centers. So this is going to be the top and bottom chord restraints. So that's critical that you get that right. If you've got a direct fixed ceiling, it's 600 mil. Yeah, so just make sure that's filled in, and then we can say OK. Now it says select objects to design. So I'll just pick one truss, Control A, and confirm. Now this part is going to take 2 or 3 or 4 minutes or something. So what goes through and engineers everything. So I will just see if I can pause, and we'll come back. All right, so that's all done now. So we've got some warnings and errors that pop up. Again, you can take note of the warnings, like there's one here, vertical truss member missing, and it'll point to where it is on this little valley. The errors, we might look for any odd errors, but like these ones that say the product's not strong enough, it just means that that truss has failed, a cord or something. And same if you get connections, so we can just close that. Now, everything that's passed will be green, and the labels that have failed will be red. Now, you may want to go around and check every truss anyway, but so let's go and pick some of these trusses to check. I should point out too that if you're just trying to check 1 or 2 trusses, when you do that members and trusses, you don't actually have to pick all the trusses. You can just pick, let's say you wanted to check this, you can just pick that one truss and check that. I mean, to finish engineering properly, you do have to run members and trusses over the whole job, but yeah, you can separate it out if you're just trying to analyze one truss quickly. But let's pick on this truss. This is one that's failing. And so we'll right click and we can go truss engineering. And this is going to bring it into single truss engineering. So we can analyze this truss on its own. Okay, so we've got our deflection curve here. So this is saying under max serviceability limit state, we've got 5.5 mil deflection. So that's down deflection, up deflection. We've got a sphere here. So that's saying that that product has failed. And you've also got all this coloring. So blue, green, it's working very easily. Once it gets that yellow, orange it's starting to get more stressed, and red is where it's failed. And this sphere is going to be pointing the worst case of the failure. So, oops. If I want to have a look at, let's try this. Let's see, hold on. Let's get rid of that coloring first. So I can get rid of all that coloring because it can be a bit confusing to look at sometimes. We go F5 and refresh it. Now if I want to pick on that chord and right click, I can say show results overview. So this is telling us how hard that chord is working. So at the moment, under combined compression and moment, 116%. So from a detailer's point of view, this is what I use mostly, just to have a look at, see how much it's struggling. Just gives us an idea of what we need to do to fix it. You don't really need to understand what everything is, just lots of red is bad and green's good. So, okay. All this stuff here, this is a 3D model. So sometimes with these particular trusses, all this gets a bit in the way. So you can alt select that truss, right click and say hide others. And we'll get that out of the way. Just remember that you've hidden it. Sometimes seems like some odd things happen, like some functionality disappears. Most of the time it's because you got stuff hidden. Just remember to restore hidden to get it back. Let's see if this load button works. Yep, so that loads, that's just telling us what loads are on the truss. This represents the roof panel. So you can tick these on or off, just get everything out of the way if we want, like the supports. Okay, so how are we going to fix that truss now? So the easiest way, if we pick on that top chord, we've got this button here, and this lets us add and remove webs. So if I want to add another web here, I can do that, and it's added in another web pair, and then I can come back to truss engineering and solve. And that's probably going to be enough. So now this has gone green to say that it's passed, and we've got a green tick here. So that truss is now passed. If we want to have a look at our chord again, see now it's at 95%. And this these trusses fail under combined compression and moment and combined tension and moment. Most of the time, that's how they fail. But yeah. All right. We also have where is it? Capacity summary results. So this is probably more relevant for your engineer. So we've got all the data in Excel, and you can look through all this information. Tend not to use it as a detailer, but your engineers could be interested in that. Okay, so we're happy with that truss now. So if we want to go to the next truss, F2, and let's pick on, let's just pick on one of these trusses that's passing in a way. Go truss engineering. We'll have a play around with this. All right, so if I say this, I think this has got too many. Oh, so this is where, now I'm picking on that, trying to get that plus, and it's not coming up. Remember I said about the hidden, just go restore hidden. So you got to remember this is a 3D model and this is just a section of it. Now when I pick it, that plus comes up. So if I right click on the plus, I can go remove web pair. If I think that's got too many webs, I might even do one more. Let's see. And I can do the same on the other side, but I can also, can I pick all these at once? Yeah. Let's say I pick those, I can right click and say mirror and replace. So if the truss is symmetrical like this, that's quite a good function. So let's solve that, see if that's any better. And that's still passed. So yeah, so this is a good area to play around in and fine tune those trusses. Okay, so let's say we're gonna delete a web. Let's say that had to be deleted for whatever reason, maybe air conditioning going through or something. So we've got some other ways we can stiffen up that truss. We can box chords. So this is just a normal box stud function. So we might use this one. Pick the stud. Let's say we're going to go from here through to here. Right, so that's boxed. I don't know if that's enough to make the truss pass. Probably not. No, not even close. And then the other thing we can do is add a side reinforcement, and that will be in connection details. And we'll come down to trusses and side reinforcement. So it's going to be, say, this chord, confirm. And let's say we're going to add that side reinforcement from here to here. And we can add it to the left or the right or both. Right, so if you're standing at the bottom, because I picked down here, looking up, the left will be the back, the right will be at the front. So let's add it to both sides in this case and solve that, see if it makes any difference. And that's actually passed it, which is good. I'm going to go F5. So if you want to delete those now, you can just pick on it and delete. The box stud, you might want to use this remove boxing. And if you want to add that web back in, so we can use the add profile to draw webs in. So you can also copy them and move them around, but if you use this function, don't try and fill any of this in, just use this pick. Pick the member that you're trying to emulate, say that one, which is a web, and it'll fill all this in correctly, and the profile direction, and then we're just going to add a web from here to here, and that'll put that in. But you can let's do a save. You can move these around. Let's say I want to align that. Maybe I wanted it vertical. You can copy and that works fine. Have to add the joint in. So whatever's easiest. Yeah, and you're going to go around all your trusses and and do that. Now, once you've finished doing that, we'll say close. So you'll notice here our labels are orange. So orange has tentatively passed, red has failed. You must run members and trusses again at this point. It just double checks that we haven't changed loads or shape of the truss that might affect other trusses and so on. So we must run that members and trusses again, and then everything will go either green or red. So I won't do that again at this point, but so we'll just continue from there. The next thing we can do in relation to engineering, reaction table. So if we pick that, and we can add the reactions. So you might be using this to look at your tie downs, and it'll put the these labels here as to what it's relating to. And this is your uplift results. The next thing you want to do is be able to do some panel drawings. So we're going to come in here for our engineering panel drawings. And let's just pick one of these trusses at the moment. Let's say this one. Say yes. It's warning me that engineering hasn't been run on the whole job, hence the orange labels, which is correct. And do I really want to continue? Let's say yes. I'll just pick the results drawing. Okay, now it says calculation out of date because it is out of date. I haven't run members and trusses. But this is mainly what your engineer is going to be looking at. The members have passed by 70%, connections are at 94%, and we've got our user added load. That was our area load that we added in. Yeah, and that's basically it. So you can run those on all the trusses and just print them as normal. And yeah, that concludes engineering. Thank you.
Okay, now it's time for questions and answers. There is at least one question for David for you.
Yeah, it's asking about the 1.1 kilonewton point load, and does the software place it anywhere, including at the tail of the truss? So yes, it's not exactly at the end. I think the code tells us where we have to put those 1 kilonewton loads. It's a little bit vague. It just says to put it in the worst case. It's more specific at the tail, and I think it's a little way, like might be a couple of 100 mil up from the very end, but it is applied to the tail anyway. Okay, if you're designing with other codes, what do you do? So there's the building code button up in the ribbon bar, and you can simply press that and change it to, if you're using the Chinese code or the Euro code. Yeah, I think that's what we have. We have the Australian, Chinese, Euro, UK code. I think that's your choices. Does the software automatically place bracing noggins, tie rods in the roof? No. Wall frames, we can, in the framing tools, you can set it up to. We don't use a lot of tie rods in Australia, at least not for steel framing, but yeah, we can do that, but we'd have to set it up a bit. Do we need to change the service class depending on truss material? I don't think so. We're really just doing that, working with the AS 4600 NOA. Yeah, I'm not 100% up on the code and the different service classes. I think we're really just doing the residential and commercial stuff. I'm not sure what happens when you get to things like childcare centres and stuff that might be a classed as post-disaster buildings. Yeah. Can we view and change the combination factors on the loads? No. Can you view them? I think you can list them somewhere and see them. I guess from a detailer's point of view, we kind of don't care because the codes specify what, as Vertex, is what we have to do to engineer it. From a detailer's point of view, we're not trying to change that, and we're going to do it as per the code. So you can't change them, but I think in the results you can see what those load combinations are. Load combination based on Indian code? No. Yeah, we've only got those codes in the system that I mentioned. Is the AS code adapted from ASCE? I don't think so. I don't know where I guess we just come from the. I don't know how the codes are developed, but I think it is a standalone code. I don't think it's copied off anything else. Does it do floor truss engineering? Yes, we do floor truss engineering. So I think we've got another webinar coming up related to floor trusses. It's much the same process, except we don't have wind on floor trusses. But I think, yeah, I was going to go through and do that one. How do you add additional screws to get a truss to pass? So you don't actually have to add the screws. The system, when we hit solve, that will work out the number of screws required. It'll for an inline truss, it'll put up to 4 screws. You can manually add that 5th screw by redoing the joint and then changing the number of screws in the joint. But you've got to be a little bit careful that the system's not going to work out that screw spacing and the allowable edge distance. So you're going to have to make sure that you can put too many screws in. Yeah. Is the self-weight taken automatically as loads in calculations? Yes, the system will work out the self-weight of the truss. How do we analyze the hot rolled supports? We can't analyze the hot rolled supports. We can analyze beams and things with FEA, but it's unless you're an engineer, you're not going to be able to use FEA. So yeah, so from a general detailer's point of view, that's no, we can't do it. Is it possible to incorporate the brackets into the structural analysis? Not at the moment. We can add the brackets into the model, but we're not analyzing them as such. Interior sealing is permeable. So that's where I was saying, if you've got no sealing, like a carport with no sealing, then those wind loads have to get transferred up to the top chords of the truss. So if you've got a suspended ceiling or those lightweight ceiling tiles that you can, push up with your fingers. So if the wind comes through your windows, like in a cyclone or something, I guess, and that ceiling just gets blown up, then that wind load's going to get transferred to the top chords. So that's what that button's talking about. It's just transferring those wind loads to the top chords. Apply wind loads. How about if we detail based on the design criteria from engineers' structural drawings? Yeah, so you've got to be, so basically what I think what you're saying here is if the engineer has specified some wind loads, then yes, you can fill in that sheet with that, whatever that criteria is, but you've got to be careful that you're referring to the same wind code. So we are using 1170.2, which is for residential and commercial buildings. 4055 is for residential buildings only. That's in Australia. This is your N2, N3 ratings. So if you have some drawings and they're specified as N3, then you're going to have to get your engineer to convert that to 1170.2. So you can't just take I think the two codes are aligned now, but they never used to be. But yeah, talk to your engineer. I wouldn't just fill those in. When running engineering, more errors occur that prevent running of the engineering. Is there a typical process in terms of both how we draw walls and what roof connections you do to minimize these errors? Yeah, so there's a few things that stop engineering from working. One is not putting all your corners on your walls when you draw them in. So make sure your corner connections are joined. It doesn't always stop it. It sometimes stops it. If you've got two-story buildings and you've got upper walls overlapping beams, that can stop it. So really it's just get your architectural model correct first, walls the right heights, supports in the right place, and then it's generally pretty right. But just pick on those errors and they should highlight where the issue is, and then hopefully you can work it out from there. Does it only provide design for frames, or are there also design results for the screws used? So in the background, you specify what screw you're going to use with your trusses. That engineering data is in the system, so you can use different screws. So yes, the screws are engineered, and the quantity of screws are engineered, and they're engineered to suit the profile. So it's probably worth pointing out that it's not very often that the actual screw fails. So very rarely does the screw fail, as in the screw itself shearing. It is usually the profile failing and due to tear out. So putting bigger screws in doesn't usually solve much. What type of connection do trusses use besides screws? Do these use bolts too? And also will the framer know exactly what to put in the connection as in the... Okay, so Vertex does not design the truss-to-truss connection. So when we put those truss-to-truss connections in, although we do specify how many screws are there, it's just using that as a load path to say that this truss is connected to that truss. You'll have to have your engineer check the actual truss-to-truss connection. And you may get away with using screws. You might need brackets or truss boots or whatever. But yeah, we're not actually engineering that truss to truss. What type of connections do trusses use besides screws? Oh, that's the one I just read. Sorry, I highlighted the wrong one. Yeah, we don't, just in relation to that too, do we use bolts? We don't actually see a lot of bolts. There's probably no reason why you can't use bolts, but typically 3 or 4 screws is better than 1 bolt, and it's usually because of that tear out. Yeah. Does the truss engineering work in any other material picked when creating the trusses? So we can engineer any C profile. It has to be a C profile. We can't do U profiles. We can't do any other strange shape sections. We use another piece of software to work out engineering data for that profile, and we add that into your system. So if you've got a specific C profile, you know, it could be 82 by 53 or something odd, then as long as that complies with the code, because there are limitations on it, we can put that into the system, and Vertex can engineer that. Can we create a new screw type with our capacity and check and truss engineering? So essentially, yes, you can come to us with your own screw capacities, and I think we can put those in. Most manufacturers have worked out their capacities, so yeah. Are standalone parapet trusses testable for lateral load? I guess the simple answer for that is no, but if you go into that engineering where we're looking at the top chord restraints, bottom chord restraints, you could push those right out to 6 meters or something. And I guess that would come close to designing it correctly, but I think in that case, I'd be talking to your engineer as well. I don't want to say that we can engineer parapet trusses. They just work a little bit different, so I'm not sure about that entirely. Where can we edit screw capacities and are in a combination possible? We need to do the screw capacities for you, so that's not something that you can look at yourself. Sorry, the connection from web to top and bottom cords, not between trusses.
Maybe was related to that question earlier. So
yes, yeah, I'm not sure I quite understand. I think, yeah, we've covered the connections between trusses. And I think in terms of screws, Vertex will engineer all the screw connections with quantities for each truss, but not between trusses. Can we do truss engineering for outer plane trusses? Yes, we do outer plane trusses. Process is basically the same. And you can do combinations of them too. So you can put inline trusses and outer plane trusses in the same model if you want. Do we do overall engineering webinar in the future for truss and wall frames? We don't have the ability to engineer wall frames at the moment. So yeah, I guess the answer to that one's no. And I think that's all I've got.
okay, we do have some. There's a lot of questions. So thank you about all those questions. Maybe we have not able to answer all of them. So you can contact the nearest Vertex office to have more information about the truss engineering, and they will also help you with when you are maybe buying the truss engineering, that what it can do and what it can't do. Thank you about those questions. There was also one question related to Revit, and can you import the Revit file, PIM file? You can always import IFC files and use them as a reference. So about the next webinars, we have webinar series related to these trusses, and there are upcoming webinars as shown here, and you will also be find newsletters about these, and then there will be some information also in our different kind of platforms. Thank you about participating in this webinar, and there will be a recording available after a few days. I don't know exactly when, but the recording will be in YouTube, and also there will be a link in our webpage to that webinars as well. So thank you again, and have a nice day.
Okay,
Goodbye.
thanks.